Hello all, I'm Alan Rose. I'll be talking about a flexible form factor digital optical current sensor that has been used around the world in utility applications for 15 years. However, recently we've added triple redundancy to this product. GE makes an optical fiber current sensor that has a wraparound cable for power utility applications where breaking the power line is difficult. The diagram to the lower left shows the breakdown of the basic components. The photo to the right shows the flexible cable product in a power cable application, in this case an undersea cable. The basic components are the flexible cable with a sensing fiber inside wrapped around a power conductor. The optical sensor is an inline Sagnac interferometer that is actively modulated. Light is produced, detected, and the modulator is actively controlled by the electronics of the sensor. The fundamental output is an IEC 61869 digital output. However, for many years, the only way to add redundancy is by adding more units with cables and boxes. This work is to place 3 sensors inside the wrapping cable and box. The engineering to place 3 sensing fibers inside a flexible cable requires optomechanical and materials expertise. The sensing fibers can interact with each other and reduce the performance of the sensor, especially over temperature, as materials expand and contract in the plastic cable. The drawing to the left shows the end of the wraparound cable and the layers of cables and tubes, purple, yellow, green, to protect the fibers in the utility environment. The red capillaries with the mirrored fibers lay inside this matrix of tubes. The triple sensor cable was then attached to a housing shown in the drawing on the left with 3 modulators and mated to electronics to measure the current. The triple sensor was then fully type tested to the IEC 61869 standard for protection and metering applications. Type testing was performed at a third-party lab. The photo to the left shows a triple sensor device in test at a high-power lab with various reference CTs for comparison. The 3 sensors inside of the single cable were taken over temperature from -50 to +50 and scale factor error measured in the center of the top figure there, shown in the top figure there. This is the most rigorous test and goes over the full temperature range of use for the device, where the optomechanical interactions can throw the scale factor off. The maximum temperature the cable can withstand is +80 C. The next test was a transient current test at 216 Ka peaks for a 60 Hertz, 180 millisecond transient burst. Multiple bursts were taken and for the sensor to perform very well with a 0.4 composite error as shown in the figure on the top right. The linearity of the sensor was then tested from 1% to 120% of the 1 Ka rated current, and as you can see, meets the IEC 0.2S accuracy class. Finally, the sensors were taken over the frequency from 2 kilohertz to 60 hertz, and once again meet the 0.2S accuracy class over this frequency range for the digital output. This will allow for power quality measurements beyond the 13th harmonic. In conclusion, this new wraparound optical sensor with triple redundancy meets the IEC 0.2S accuracy class over temperature, frequency, and linearity. Can also meet protection applications with multiple offset asymmetric currents with 1.5% at the peaks for a 216 Ka peak.